Good afternoon, students. Myself, Dr. Satyanarayana Bhatt, HOD, Department of Physics. In Excel College, in our department, we have 30 plus staff lecturers, well qualified, well experienced staffs we have. Now I have experience more than 20 years experience I have in a teaching field, PU teaching field. We are teaching with NEET, JEE, NGA and different competitive exams. We are providing coaching for you, all PUC students as well as NEET long term also. Now here students, just now yesterday we got NDA results. Our 11 students, they qualified in a NDA preliminary exam and they are qualified for SSB interview. In the next, this is the first phase and second phase, one more exam is there and many more students are waiting their result. Definitely many more students will qualify in NDA also. In a different stream we are giving coaching. Now today I am going to discuss some physics concept in your SLC syllabus, that is current electricity. Now students, current electricity, electric current. Now I hope you know basics about electric current and charge. In order to understand what is electric current, we should know what is a charge and flow of a charge, etc. Now first students, what is a charge? Electric charge. Electric charge in we represent as a Q here, charge. Representation of charge is Q. Now charge ಅನ್ನು Q ಅಲ್ಲಿ represent ಮಾಡ್ತೇವೆ, Q symbol ಅಲ್ಲಿ. Now can you recall what is the charge? I think in your 9th class you studied about electric charge. What is the charge? Now electric charge means it is a fundamental property. Fundamental property, ಮೂಲಭೂತ property of any of elementary particles. If you take an elementary particle, it's the fundamental property. Elementary particles fundamental property, that is the electric charge. Now based on this electric property, if you have two elementary particles, they come close together, they will experience electrostatic force of attraction or repulsion. Depending on the type of charge, you know that there are two types of charges. One is positive charge, negative charge. And properties of fundamental properties of charges also you know, that is like charges repel each other, unlike charges attract each other. Now if you take two like charges, like means if I take a positive plus Q and plus Q, if these two charges you bring close together, these are like charges, they repel each other, repulsive force. If I take a minus Q and minus Q, negative charge, they also repel each other. If I take a unlike charge, 1 plus Q and 1 minus Q, they attract each other. They attract each other. This is a fundamental property of electric charges. Like charges repel and unlike charge attract each other. Now based on this property of a charge, another important property is their scalar quantity. Hope you remember what is scalar and vector. Scalar quantity means scalar. Electric charge is a scalar quantity, and scalar quantity which does not have any direction, which has only magnitudes. This has a magnitude and no direction. No direction. The physical quantity which has only magnitude, that means it has a definite value but no direction, no specific direction. Such quantities are called as a scalar quantity. This is a electric charge which has a value, that is Q is equal to, for example, plus 10 with the unit. Hope you know what is the unit of electric charge. Unit of charge is Coulomb, right? Coulomb. Unit of charge is Coulomb, right? Yes. Unit of charge is Coulomb. I will define what is Coulomb, what is 1 Coulomb, or when we can say charge is 1 Coulomb, etc. Everything I will define. Now here this 10 plus 10, that is the magnitude, plus 10 is the magnitude, and in order to represent the magnitude with a proper unit we have Coulomb. Coulomb is the unit, proper unit. That is the scientist name, and capital C is the representation. What is this Coulomb, etc. I will define using a Coulomb's law. And it has no direction. This is a scalar quantity. And these are the basic property of charge. Using this property of charge, we can define what is current. Okay, that is the rate of flow. Now, first I will define what is this Coulomb, 1 Coulomb. In order to define this Coulomb, we need Coulomb's law. Now, before entering into current electricity, I will recall some of the concept already you know. With the help of that concept, I am going to discuss about electric current. Now, first we should know Coulomb's law. Coulomb's law. This Coulomb's law explains the electrostatic force between two stationary point charges. If I take two stationary point charges, I will take a plus Q here, Q1, another charge plus Q2, which are separated by a distance R. R is the distance of separation. Okay. Now I have to get electrostatic force of a repulsion here, plus Q that repel each other like charges. What is the repulsive force between these two charges? That I have to find. This is a repulsive force here. F. I'll take a force experienced by first charge due to second charge is F12, and force experienced by second charge due to first charge is F21. I'll write here F21. Now, in the magnitude, we can define Coulomb's law as electrostatic force of attraction or repulsion between two stationary point charges, which is directly proportional to the product of magnitude of two charges. That is, I have two charges here, Q1 and Q2. What is the magnitude of charge Q1? That is Q1 modulus value. Magnitude means modulus value. I will take another charge Q2. It's a modulus value, modulus Q2. This is a product of two charges, magnitude of two charges, and it is separated with a certain distance here. Separated with a smaller distance, two charges. Distance of separation is R here. So that inversely proportional to square of the distance between two stationary point charges. This force is inversely proportional to square of the distance. That means as the distance of separation increases, what about electrostatic force? Force decreases. As the distance increases, force decreases, right? That is, as R increases, electrostatic force F decrease. And by using this product, we can say as the magnitude of charge increases, electrostatic force also increases. Together we can write as F is proportional to magnitude of Q1. I will simply write as Q1. Magnitude of Q2, simply I write as Q2. divided by square of the distance. Square of the distance. Now what is this? This is a net force. Correct? Force experienced by two stationary point charges. Here this may be repulsive here. Suppose I take one minus here, this may be attractive force, but the magnitude is same. Magnitude of force is same. Now this can be equate F with equality constant K into Q1 Q2 divided by R square. Correct? Constant K. What is that constant K? Constant K. If you have any doubts, you can ask in between students. ನಿಮಗೆ ಏನೇ ಡೌಟ್ಸ್ ಬಂದ್ರು in between you raise your question. I will clarify on board itself. These are the fundamentals. Before this going to discuss about current electricity, I am discussing this fundamentals. You should know this already from your 9th class. Now this is a product Q square. If I take a Q1 and Q2 are the same, I can write Q square also. R is the square of the distance, right? Now this gives the force. What is the unit of force? Hope you know unit of force. Unit of SI unit of force is Newton. I can get unit of K here. Unit of K. Constant K unit I can write. Yes, K. K denotes constant here. Yes, K denotes constant, where K is a constant. It is known as a Coulomb's constant. Coulomb's constant. Coulomb's constant. If you have any such doubts, so you can ask please. Coulomb's constant, and value of K is 1 by 4 pi epsilon naught is the value of K. If I substitute epsilon naught value, K is a constant, Coulomb's constant, it is called as a Coulomb's constant, and another term we got here, epsilon naught. What is this epsilon naught? Epsilon naught is called as absolute permeability. This is permittivity. Sorry, absolute, I will write here, absolute permittivity. Permittivity, absolute permittivity. What is the meaning of this permittivity, absolute permittivity? This is for air or vacuum. This value is for air or vacuum. Now what it means, absolute permittivity? Permittivity means how much that medium permits, allows electric field to pass through that medium. ಆ ಮೀಡಿಯಂ ಅಲ್ಲಿ ಎಷ್ಟು ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ಲೈನ್ಸ್ ಅನ್ನೋದು ಪಾಸ್ ಆಗಲಿಕ್ಕೆ ಬಿಡ್ತದೆ, ಅಲೌ ಮಾಡ್ತದೆ ಅಂತ. ದ್ಯಾಟ್ ಟೆಲ್ಸ್ ಯು ದಿಸ್ ಅಬ್ಸಲ್ಯೂಟ್ ಪರ್ಮಿಟಿವಿಟಿ. ಯಾವುದೋ ಒಂದು ಮೀಡಿಯಂ, ಫಾರ್ ಡಿಪೆಂಡಿಂಗ್ ಆನ್ ದ ಮೀಡಿಯಂ ದಿಸ್ ವ್ಯಾಲ್ಯೂ ಚೇಂಜಸ್, ವ್ಯಾಲ್ಯೂ ಆಫ್ ದಿಸ್ ಚೇಂಜಸ್. This is for air or vacuum. This absolute is for air or vacuum. Air or vacuum we write this absolute value, and for other medium, depending on the medium, this value changes. Okay, this value for air or vacuum I will write here. This is 8.854 into 10 power minus 12. Now I have to get a unit of this. How to get a unit of this epsilon naught? I have to find a unit of this epsilon naught. How I can get unit of this? I have to get a unit of K, right? How to get unit of K? You take this unit of force. I will modify this equation as K equal to, students, hope you can understand, K equal to, I have to bring this Q1 Q2 R square to other side. You bring this to other side. If you take this to left side, then how I can write F into R square, this goes to numerator, F into R square divided by Q1 Q2, right? Q1 Q2, correct? Hope you got this. F R square, that is the K, correct? Divided by Q1 Q2. Now what is the unit of F? Unit of force is Newton. I'll write here. Unit of force is Newton. And unit of R is the distance. What is the SI unit of distance? SI unit of distance is meter square, R square, so that unit of R is distance is meter square. Next, divide by Q1 Q2. Students, some of you have doubt there. What is Q1 and Q2 you are asking? Q1 and Q2 are two charges. Should I write here? Q1 and Q2 are two charges. Q1 and Q2 are two charges here. This value of charge may be anything. Simply I will write Q1, it has some charge. Q2, another some value of charge. Its unit is Coulomb. I have given somewhere unit of Coulomb. Now this is Q1 Q2 charge unit is Coulomb, so that Coulomb square, correct? Coulomb square. And one more doubt, explain Coulomb's law again. Yes, I will explain. First I will write unit, okay? 1 minute I will explain that once again. Now here unit of K is a Newton meter square divided by Coulomb square. Now what is the unit of K? I will write here unit of K is, SI unit of K is Newton meter square. I will bring this here, Newton meter square. Coulomb square, if I take to numerator, how I can write? Coulomb square, I will take to numerator. If I take to numerator, C power, what happens? It is a plus here in the denominator. In the denominator it is plus. I would write minus, right? Power minus. I will write a Coulomb power minus 2 Newton meter square per Coulomb square I get. This is the unit of K. Now what is the unit of epsilon naught now? Epsilon naught unit. I will write here. This I will take here. See, epsilon naught, I can write epsilon naught as, I will bring this K to the denominator, 1 by 4 pi into K. This 1 by 4 pi has no unit. It has no unit, no dimension. K in the denominator. Unit of K is Newton meter square per Coulomb square. That is 1 by Newton meter square Coulomb minus 2. 1 by Newton meter square Coulomb minus 2. If I take this to numerator, what I get? That is per Newton power minus 1, meter power minus 2, Coulomb power minus 2 goes to numerator, Coulomb square, correct? This is the unit of epsilon naught. Unit I get. Students, hope you understood this, how I can get unit. See, these are the concept. If you come to PUC science, in a NEET and JEE, this kind of derived units, you should know how to do this, because you can't by heart. There is no by hearting system here. By hearting does not work also in competitive exams. So that instead of by hearting, you should know in a whole exam question itself, you should know how to derive that units. By using fundamentals, if you have fundamental concepts, by knowing fundamental concepts, we have to derive its required units. That is a thing is required in PUC here, in a competitive exams. That all these shortcut methods and how to get these derived units, its dimensions, everything we will discuss in a short here. In different methods we have to get it. That is, I will use this epsilon naught unit here. That is Coulomb square. I will write first positive term per Newton per meter minus 2. This is the value of epsilon naught. Okay. Yes, sir. Some of you have any doubts? Coulomb's law. Yes, I will explain that again. Then what is other doubt? Yes, I'll recall all this concept once again. Students, maybe most of you are not remembering this concept, Coulomb's law. I will start once again here. Say what I discussed here is Coulomb's law. This Coulomb's law states the electrostatic force between two stationary point charges. That is, here I have taken as a charge Q1 and charge Q2. Okay, two charges I have taken at a separate distance of R. Distance of separation is R. Okay. Now this Q1 which experience force due to another charge Q2 and Q2 experience force due to another charge Q1 here. Its direction is different because like charges that repel each other. ಎರಡು ಲೈಕ್ ಚಾರ್ಜ್ ಇದೆ, ಒಂದೇ ಟೈಪಿನ ಚಾರ್ಜ್, ಅದೇನಾಗ್ತದೆ ರಿಪೆಲ್ ಆಗ್ತದೆ, ಒಪೋಸಿಟ್ ಡೈರೆಕ್ಷನ್ ಅಲ್ಲಿ ಮೂವ್ ಆಗ್ತದೆ. ನಾವು ಆ ಫೋರ್ಸ್ ಎಷ್ಟು, ಆ ಒಪೋಸಿಟ್ ಡೈರೆಕ್ಷನ್ ಅಲ್ಲಿ ಎಷ್ಟು ಫೋರ್ಸ್ ಅದು ಎಕ್ಸ್ಪೀರಿಯನ್ಸ್ ಮಾಡ್ತದೆ, that we are discussing here. That we can get by using a Coulomb's law. What Coulomb says is, he says the electrostatic force between these two charges that is proportional to product of magnitude of these two charges. Magnitude means ಇಲ್ಲಿ ಮೈನಸ್ ಇದ್ರೆ, ಸಪೋಸ್ ನೀವು ಹೈಸ್ಕೂಲ್ ಅಲ್ಲಿ ಐ ಥಿಂಕ್ ಇನ್ ಹೈಸ್ಕೂಲ್ ಯು ಯೂಸ್ಡ್ ಮಾಡ್ಯುಲಸ್ ಕಾನ್ಸೆಪ್ಟ್. ಆ ಮಾಡ್ಯುಲಸ್ ಅಲ್ಲಿ ನೀವು ಹೇಗೆ ಬರ್ದಿರ್ತೀರಿ, ಮಾಡ್ಯುಲಸ್ ಅಲ್ಲಿ mod of -1, what is the value of mod of -1? Students, can you reply? What is the mod of -1? You know this. What is the mod of -1? Anyone can reply? Hope you know this concept, modulus concept. Mod of -1, or if I write mod of -2, mod of -2, how much I have to write? Modulus value. Mod of -1 is 1, right? Plus 1. Mod of -1 is 1 and modulus of -2 is 2 plus 2 plus 2. This is correct. Ankit Prasad, yes, it is correct. This is a plus, right? Modulus means it is a positive. We have to write a plus only. Correct? That means if I write here Q1, suppose it is a negative charge. Q1 is a negative, suppose. What is the value here? I have to write plus only. Plus value I have to write. ಅದೊಂದು ವೇಳೆ ನೆಗೆಟಿವ್ ಇದ್ರೆ ನಾನು ಪಾಸಿಟಿವ್ ಅಲ್ಲೇ ಬರಬೇಕಲ್ಲಿ. If suppose Q2 ನೆಗೆಟಿವ್ ಇದರಲ್ಲಿ -10 ಅಂತ ಇದ್ರೆ ನಾನೇನು ಬರಬೇಕಲ್ಲಿ Q2 +10. +10 is the value. That means only product is important for us. The force depends on a magnitude, ಅದರ ನಂಬರ್ ಮೇಲೆ ಡಿಪೆಂಡ್, not depending on the sign. Correct? Magnitude of force. Hope you understood this. And inversely proportional to square of the distance. Inversely proportional meaning ಏನು? What is the meaning of this, students? Inversely proportional. Inversely proportional means what? Inversely proportional ಅಂದ್ರೆ ಡಿನಾಮಿನೇಟರ್ ಅಲ್ಲಿ ಬರ್ತದೆ ನಮಗೆ. As this value distance increase ಆಗ್ತಾ ಹೋದಾಗೆ, as r increases, f ಏನಾಗ್ತದೆ ಡಿಕ್ರೀಸ್ ಆಗ್ತಾ ಹೋಗ್ತದೆ. ಕರೆಕ್ಟಾ? As r value increases, f value decreases. As r value decreases, denominator ಅಲ್ಲಿ ಇರೋ ವ್ಯಾಲ್ಯೂ ಡಿಕ್ರೀಸ್ ಆದ್ರೆ ವ್ಯಾಲ್ಯೂ ಆಫ್ ಫೋರ್ಸ್ ಏನಾಯ್ತು, ಇನ್ಕ್ರೀಸ್ ಆಯ್ತು. ಕರೆಕ್ಟಾ? ಅಂದ್ರೆ ಚಾರ್ಜಸ್ ಹತ್ರ ಬಂದ ಹಾಗೆ, as you bring these charges close together, force ಏನಾಗ್ತದೆ, ಇನ್ಕ್ರೀಸ್ ಆಗ್ತದೆ. ಕರೆಕ್ಟಾ? As you take these charges away, separate, then what about force? Force decrease, right? Force decrease. That is the meaning of inversely proportional. Now hope you understood, all of you understood these concepts. Why I have taken a product here and inversely proportional. Hope you understood, students. Yes, correct. Ananya Hiremach, Ankit Prasad, yes. If one value increases, other decreases. Yes. Now you understood this. So concept of inversely proportional and product, right? Now together, ಇದೆರಡನ್ನು ಒಟ್ಟು ಸೇರಿಸಿದ್ರೆ I can write like this, correct? Directly proportional Q1 Q2, inversely proportional to R square. ಅದನ್ನು ನಾನು ಇಲ್ಲಿ ಬರೆದಿದ್ದೇನೆ, correct? Here it is there. And this proportionality, how to I can remove with the help of one constant. This constant is the Coulomb's constant. That is the Coulomb's constant, correct? This Coulomb's constant, its value is 1 by 4 pi epsilon naught. If 4 is number, pi, what is the value of pi? Pi is 22 by 7. ಇದೆಲ್ಲರಿಗೆ ಗೊತ್ತಿದೆ ನಿಮಗೆ. Pi value is 22 by 7. We write this as 3.14 in short. ಇಲ್ಲಿ ನಾವು ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡುವಾಗ ಕಾಂಪಿಟೇಟಿವ್ ಎಕ್ಸಾಮ್ ಅಲ್ಲಿ we most commonly we use as a 3.14. ಇನ್ನು ಕೆಲವು ಶಾರ್ಟ್ ಕಟ್ಸ್ ಇದೆ, that I will explain later. 3.14 we use. Now this epsilon naught value is absolute permittivity. Absolute permittivity means what? Absolute permittivity means what? How much that medium, ಇದು absolute air ಅಥವಾ vacuum ಗೆ, air or vacuum ಆ medium ಎಷ್ಟು allow ಮಾಡ್ತದೆ electric field ಅನ್ನು ಅಂತ. That is the ability of the medium to allow electric field lines. That is the absolute permittivity. Its value is for air or vacuum 8.854, 10 power minus 12. ಅದಕ್ಕೊಂದು ಒಂದು ವ್ಯಾಲ್ಯೂಗೆ ಒಂದು ಯೂನಿಟ್ ಅಂತ ಇರ್ತದೆ. That unit is Coulomb square per Newton per meter square. ಇದೆಲ್ಲಿಂದ ಬಂತು ನನಗೆ? How I got this? By using the same equation again. Same equation I have to use. That is first I will take a k unit. How to get a k unit? I modified here. I modified this equation. That is you take this remaining terms to other side. Then I get F into R square by Q1 Q2. Correct? ಈಗ ಇಲ್ಲಿ force in unit ಎಲ್ಲರಿಗೂ ಗೊತ್ತಿರಬೇಕು. Force in unit. Force in unit is Newton, and R is the distance. Distance in unit ಕೂಡ ಗೊತ್ತಿದೆ ನಿಮಗೆ. That is meter square. Meter square ಆಯ್ತು. ಇಲ್ಲಿ R square is meter square ಆಯ್ತು. Q1 Q2. Q is the unit of charge. Charge in unit Coulomb. Coulomb square ಆಯ್ತು. Q1 Q2 ಆದ್ರೆ ಏನಾಯ್ತು? Coulomb square ಆಯ್ತು. ಎರಡು ಚಾರ್ಜ್ ಇದೆ ಇಲ್ಲಿ. So that Coulomb square ಆಯ್ತು. ನಾನು ಈ Coulomb square ಅನ್ನು ನ್ಯೂಮರೇಟರ್ ಗೆ ತಂದ್ರೆ ಏನಾಯ್ತು ಇಲ್ಲಿ? Coulomb square, if I take to numerator, I get Coulomb power minus 2 ಆಯ್ತು. Correct? Yes. This unit I have written here. Correct? ಈ ಯೂನಿಟ್ ಅನ್ನು ನಾನೇನು ಮಾಡಿದೆ? ರೆಸಿಪ್ರೋಕಲ್ ತೆಗೆದೆ ಇಲ್ಲಿ. ಯಾಕೆ ರೆಸಿಪ್ರೋಕಲ್? ನಮಗೆ ಎಪ್ಸಿಲಾನ್ ನಾಟ್ ವ್ಯಾಲ್ಯೂ ಬೇಕಿಲ್ಲ. ಎಪ್ಸಿಲಾನ್ ನಾಟ್ ಇದು ಯಾವ್ದರ ಯೂನಿಟ್? ಕೆ ಯೂನಿಟ್. ಎಪ್ಸಿಲಾನ್ ನಾಟ್ ಬೇಕು. ಎಪ್ಸಿಲಾನ್ ಆಗಬೇಕಾದ್ರೆ ಏನು ಮಾಡ್ಬೇಕು ಇಲ್ಲಿ? ರೆಸಿಪ್ರೋಕಲ್ ಐ ಹ್ಯಾವ್ ಟು ಟೇಕ್, ರೈಟ್? ರೆಸಿಪ್ರೋಕಲ್. ಕರೆಕ್ಟಾ? ಇದನ್ನು ನಾನು ಇಲ್ಲಿ ಬರ್ದೆ. ದಿಸ್ ಇಸ್ ಅ ಕಂಪ್ಲೀಟ್ ಕಾನ್ಸೆಪ್ಟ್ ಆಫ್ ಕೂಲಂಬ್ಸ್ ಲಾ. ಕೂಲಂಬ್ಸ್ ಲಾ, ಕರೆಕ್ಟಾ? Yes, one of the student is asking, what is your qualification? Qualification you are asking. See, qualification, I have done MSc and PhD. PhD, that is in ISRO. ISRO collaboration I have worked about solar cell. Solar cell field ಅಲ್ಲಿ PhD ಮಾಡಿದೆ. ನೀವು ಈ ಕ್ವಾಲಿಫಿಕೇಶನ್ ಕೇಳ್ತಾ ಇದ್ದೀರಿ. Better you ask physics questions. If you have any physics questions, physics doubts, better you ask that. Yes, can you teach resistance? Yes, definitely I will teach resistance. After discussing current, I will go for a resistance. Okay, I will teach that also. Everything I will discuss. Students, shall I go for next concept? Now I got this. What is charge? Correct? Charge concept you understood. Now I have to discuss about current. Okay, now we have the concept of charge. Charge q ಅಂದ್ರೆ ಏನು ಅಂತ ಗೊತ್ತಾಯ್ತು ಈಗ. It's a SI unit is Coulomb. SI unit Coulomb ಗೊತ್ತಾಯ್ತು. Next I will discuss about a current. ನಾವಿಲ್ಲಿ ಚಾರ್ಜ್ ಅಲ್ಲಿ ಇನ್ನೊಂದು ಪ್ರಾಪರ್ಟಿ ಇದೆ. ಚಾರ್ಜ್, if you take any one conductor, you take one conductor, this is a metal, for example metal. This metal, it has a very large number of free electrons. Very large number of free electrons ಇದೆ metal ಅಲ್ಲಿ. That is the metal. Now if you take any metal, you take any metal, you take copper, aluminum, gold, silver, any metal you take, this contains nearly 10 to the power of 28 free electrons per unit volume. I'll write meter cube, per meter cube. ಒಂದು ಯೂನಿಟ್ ವಾಲ್ಯೂಮ್ ಅಲ್ಲಿ ಒಂದು ಮೀಟರ್ ಕ್ಯೂಬ್ ನೀವು ಒಂದು ಬಾಕ್ಸ್ ತಗೊಂಡ್ರೆ, ಒಂದು ಮೀಟರ್ ಕ್ಯೂಬ್ ಸೈಜ್ ಆಫ್ ಮೆಟಲ್ ಅಲ್ಲಿ ನಿಯರ್ಲಿ 10 ಪವರ್ 28, ದಿಸ್ ಅ ವೆರಿ ಲಾರ್ಜ್ ನಂಬರ್, 10 to the power 28 free electrons ಇರ್ತದೆ. And these free electrons not at rest. Are not at rest in metals. These free electrons are not at rest. ಅದು ಯಾವುದೇ ಇಲೆಕ್ಟ್ರಾನ್ ಕೂಡ ರೆಸ್ಟ್ ಅಲ್ಲಿ ಇರುವುದಿಲ್ಲ. Why it is not at rest? Because of thermal energy. Temperature ಇದೆ at absolute zero means 0 Kelvin. ನಿಮಗೆ ಟೆಂಪರೇಚರ್ ಯೂನಿಟ್ ಗೊತ್ತಿದೆ. ಟೆಂಪರೇಚರ್ equal to 0 Kelvin. 0 Kelvin. Kelvin is a unit. 0 Kelvin ಅಂದ್ರೆ ನಾವು absolute temperature ಅಂತ ಹೇಳೋದು. Zero Kelvin ಅಂದ್ರೆ absolute zero ಅಂತ ಹೇಳ್ತಾರೆ. Absolute zero. But absolute zero ಅಥವಾ 0 Kelvin practically not possible. Everyone knows this. ಈ ಟೆಂಪರೇಚರ್ ಅಲ್ಲಿ ಮಾತ್ರ ಇಲೆಕ್ಟ್ರಾನ್ಗಳು ಮೂವ್ಮೆಂಟ್ ಅಲ್ಲಿ ಇರುವುದಿಲ್ಲ, ರೆಸ್ಟ್ ಅಲ್ಲಿ ಇರ್ತದೆ. ಬಟ್ ನಾವು ರೂಮ್ ಟೆಂಪರೇಚರ್ ಬರುವಾಗ, ರೂಮ್ ಟೆಂಪರೇಚರ್ ಎಷ್ಟು? ರೂಮ್ ಟೆಂಪರೇಚರ್ ಎಷ್ಟು? ರೂಮ್ ಟೆಂಪರೇಚರ್ is is nearly, I will write 27 degree ನಾವು ತಕೊಂಡ್ರೆ ರೂಮ್ ಟೆಂಪರೇಚರ್. ಇದನ್ನು ಕೆಲ್ವಿನ್ ಕನ್ವರ್ಟ್ ಮಾಡಿದ್ರೆ ಎಷ್ಟಾಯ್ತು? 273 ಆಡ್ ಮಾಡಬೇಕು, ಕರೆಕ್ಟಾ? ದಿಸ್ ಇಸ್ ಈಕ್ವಲ್ ಟು 273 ಪ್ಲಸ್ 27, ಟೋಟಲ್ ಎಷ್ಟಾಯ್ತು? 300 ಕೆಲ್ವಿನ್ ಆಯ್ತು, ಕರೆಕ್ಟಾ? ಇದು 0 ಕೆಲ್ವಿನ್ ಅಂದ್ರೆ ಅಬ್ಸಲ್ಯೂಟ್ ಟೆಂಪರೇಚರ್. ಆಟ್ ಅಬ್ಸಲ್ಯೂಟ್ ಟೆಂಪರೇಚರ್ ಅಲ್ಲಿ ಇಲೆಕ್ಟ್ರಾನ್ಸ್ ರೆಸ್ಟ್ ಅಲ್ಲಿ ಇರ್ತದೆ, ಕರೆಕ್ಟಾ? ರೆಸ್ಟ್. ಬಟ್ ನಾವು ಇರೋದು ರೂಮ್ ಟೆಂಪರೇಚರ್ ಅಲ್ಲಿ. ಆಟ್ ರೂಮ್ ಟೆಂಪರೇಚರ್ ಈ ಇಲೆಕ್ಟ್ರಾನ್ ಇಷ್ಟು ಟೆಂಪರೇಚರ್ ರೇಂಜ್ ಅಲ್ಲಿ ಇರ್ತದೆ, 300 ಡಿಗ್ರಿ ಕೆಲ್ವಿನ್ ಆಯ್ತು. ಬೈ ಅಬ್ಸಾರ್ಬಿಂಗ್ ದಿಸ್ ಥರ್ಮಲ್ ಎನರ್ಜಿ, ಹೀಟ್ ಎನರ್ಜಿ, ಈ ಹೀಟ್ ಎನರ್ಜಿಯನ್ನು ತಕೊಂಡು ಆ ಇಲೆಕ್ಟ್ರಾನ್ ಏನಾಗ್ತದೆ? ಮೂವ್ ಆಗ್ತದೆ, ಕೈನೆಟಿಕ್ ಎನರ್ಜಿ ಗೇನ್ ಆಗ್ತದೆ. These electrons, each and every electrons absorb this temperature. Because of that temperature, it absorbs heat energy. By gaining that heat energy, that is a thermal energy, that is converted into kinetic energy. What happens? At room temperature, electrons absorb thermal energy, and this thermal energy is equivalent to kinetic energy. Thermal energy is equivalent to kinetic energy ಆಯ್ತು, ಕರೆಕ್ಟಾ? ಕೈನೆಟಿಕ್ ಎನರ್ಜಿ, ಇಲೆಕ್ಟ್ರಾನಿಗೆ ಕೈನೆಟಿಕ್ ಎನರ್ಜಿ ಬಂತು ಈಗ, ಕರೆಕ್ಟಾ? ಕೈನೆಟಿಕ್ ಎನರ್ಜಿ ಬಂತು. ಈ ಕೈನೆಟಿಕ್ ಎನರ್ಜಿ ಬಂದಾಗ ಏನಾಗಬೇಕು? ಇಲೆಕ್ಟ್ರಾನ್ ಮೂವ್ಸ್ ಫ್ರಮ್ ಒನ್ ಪ್ಲೇಸ್ ಟು ಅನದರ್ ಪ್ಲೇಸ್. ದಟ್ ಮೀನ್ಸ್ ಇಫ್ ಯು ಟೇಕ್ ಎನಿ ಸಾಲಿಡ್ ಮೆಟಲ್ಸ್, if I take a metals at room temperature means 300 Kelvin alli, all these free electrons present here, they are moving randomly in all possible directions. ಈ electrons ಏನಾಗ್ತದೆ, ಯಾವುದೇ electron rest ಅಲ್ಲಿ ಇರುವುದಿಲ್ಲ. All these electrons are moving randomly in all possible directions. ಒಂದೊಂದು electron ಒಂದೊಂದು ಡೈರೆಕ್ಷನ್ ಅಲ್ಲಿ ಮೂವ್ ಆಗಬಹುದು, ಡಿಫರೆಂಟ್ ಡೈರೆಕ್ಷನ್ಸ್. ಅಲ್ಲಿ ಫಿಕ್ಸ್ಡ್ ಡೈರೆಕ್ಷನ್ ಇಲ್ಲ ಅಲ್ಲಿ ಎಲೆಕ್ಟ್ರಾನಿಗೆ, ಒಂದೊಂದು ಎಲೆಕ್ಟ್ರಾನ್ ಒಂದೊಂದು ಡೈರೆಕ್ಷನ್ ಅಲ್ಲಿ ಮೂವ್ ಆಗ್ತದೆ. ಬಟ್ ದೀಸ್ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಆರ್ ಮೂವಿಂಗ್ ರ್ಯಾಂಡಮ್ಲಿ, ಬಟ್ ಈಸ್ ದೇರ್ ಎನಿ ಕರೆಂಟ್ ದೇರ್? ಸ್ಟೂಡೆಂಟ್ಸ್, ಹೋಪ್ ಯು ನೋ ದ ಡೆಫಿನಿಷನ್ ಆಫ್ ಕರೆಂಟ್, ರೈಟ್? ಕರೆಂಟಿನ ಡೆಫಿನಿಷನ್ ಗೊತ್ತಿದೆ ನಿಮಗೆ? ಕರೆಂಟ್ ಡೆಫಿನಿಷನ್ ಗೊತ್ತಿದೆ. ಕರೆಂಟ್ ನೀವೇನ್ ಹೇಳ್ತೀರಿ? ಇಟ್ ಈಸ್ ಅ ಫ್ಲೋ ಆಫ್ ಚಾರ್ಜ್ ಅಂತ ಹೇಳ್ತೀರಿ, ಕರೆಕ್ಟ್? You are just saying current is the rate of flow of a charge, you see. But if it is just rate of flow of a charge, see, here is the flow of charge. Here is the flow of charge. I have not applied any potential difference or any battery. You have a conductor here. Just on the metal ತೆಕ್ಕೊಳ್ಳಿ. ಈ metal ಅಲ್ಲಿ large number of free electron ಇದೆ. All these large number of free electrons not at rest. ರೂಮ್ ಟೆಂಪರೇಚರ್ ಅದರದ್ದೇ ಆದ ಡೈರೆಕ್ಷನ್ ಗೆ ಬೇರೆ ಬೇರೆ ಡೈರೆಕ್ಷನ್ ಅಲ್ಲಿ ಮೂವ್ ಆಗ್ತಾ ಇದೆ. ಬಟ್ ಇಸ್ ದೇರ್ ಎನಿ ಕರೆಂಟ್? ನಾವು ಕರೆಂಟ್ ಇಸ್ ಝೀರೋ. ದೇರ್ ಇಸ್ ನೋ ಕರೆಂಟ್. ದೇರ್ ಇಸ್ ನೋ ಕರೆಂಟ್ ಇನ್ ದಿಸ್ ಮೆಟಲ್. ದೇರ್ ಇಸ್ ನೋ ಕರೆಂಟ್. ಅಲ್ಲಿ ಕರೆಂಟ್ ಇಲ್ಲ. ವಿ ಆರ್ ನಾಟ್ ಸೇಯಿಂಗ್ ದೇರ್ ಇಸ್ ಕರೆಂಟ್. ಈ ಒಂದು electrons are flowing. This dot represents electrons. These electrons are moving, but there is no current. Then what about your statement of electric current? You are saying electric current. What is the your definition of electric current? You are defining this as a flow of charge per time, right? I is equal to Q by T. ನೀವು ಬರೀತೀರಿ, correct? You are writing as current I is equal to, current symbol we are giving as a I is equal to Q by T. You are writing, correct? What is this Q by T? Q by T is the flow of charge per time. You are writing, correct? Correct? Yes. Now here in this metal, if I take here metal at room temperature, there is a flow of charges. But what I said, there is no current. Then what about this statement? What about this statement? You have to correct this statement. What is the correct statement of electric current? It is a rate of flow of a charge in a particular direction. Current I will define current as, it is a rate of flow of charges, rate of flow of charges in a particular direction. In a particular direction. This is a correct statement of electric current. Why this is a current? Just if you say it is a flow of charge per time, without applying any potential difference, ಇಲ್ಲಿ ಬ್ಯಾಟರಿ ಕನೆಕ್ಟ್ ಮಾಡದಿದ್ರು, just if you take a conductor, there is a flow of charge but there is no current. Say ನಿಮ್ಮ ಹತ್ರ ಒಂದು metal piece ಇದೆ, you touch that metal piece, you don't get any electric shock. That means there is no current. But ಅಲ್ಲಿರೋ electron rest ಅಲ್ಲಿ ಉಂಟಾ? ಇಲ್ಲ. That electron is moving, right? That electron is moving. But when this rate of flow of charge in a particular direction takes place, to get this current, we have to apply a potential difference. ನಾವು ಅದಕ್ಕೆ ಪೊಟೆನ್ಷಿಯಲ್ ಡಿಫರೆನ್ಸ್ ಅನ್ನು ಅಪ್ಲೈ ಮಾಡಿದರೆ ಈ ಕಂಡಕ್ಟರಿಗೆ, ದೆನ್ ಈ ರ್ಯಾಂಡಮ್ ಆಗಿ ಎಲ್ಲಾ ಡೈರೆಕ್ಷನ್ ಅಲ್ಲಿ ಮೂವ್ ಆಗ್ತಿರುವ ಚಾರ್ಜ್ ಏನಾಗ್ತದೆ, ಒಂದು ಪರ್ಟಿಕ್ಯುಲರ್ ಡೈರೆಕ್ಷನ್ ಅಲ್ಲಿ ಮೂವ್ ಆಗ್ತದೆ. ದೆನ್ ವಿ ಕ್ಯಾನ್ ಸೇ ದೇರ್ ಎಕ್ಸಿಸ್ಟ್ ಎ ಕರೆಂಟ್. ಕರೆಕ್ಟಾ? Now how I can say current? I will take this same concept. I will take another page here. Say if I have a conductor, same metal I take, same metal. Okay, this if I apply connect a battery here, on the battery ಗೆ connect ಮಾಡ್ತೇನೆ. ಇಲ್ಲಿ ಇದು ನೆಗೆಟಿವ್ ಟರ್ಮಿನಲ್ ಆಯ್ತು, ಇದು ಪಾಸಿಟಿವ್ ಟರ್ಮಿನಲ್ ಆಯ್ತು. ಪೊಟೆನ್ಷಿಯಲ್ ಡಿಫರೆನ್ಸ್ ಇಸ್ V. and here a large number of free electrons exist. Large number of free electrons ಇದೆ ಇಲ್ಲಿ, correct? Now what happens if I apply a potential difference ಅಂದ್ರೆ ನಮ್ಮ water current ನಾಗೆ, if there is a height difference, water flows, right? In the same way potential ಇಲ್ಲಿ negative ಇದೆ, lower potential, this is positive means higher potential, negative means lower potential, positive means higher potential, higher potential is positive. Water current, we say water current, like ಇಲ್ಲಿ electric current ಅಷ್ಟೇ difference. What is water current? Water ಯಾವಾಗ flow ಆಗ್ತದೆ ಒಂದು ಪ್ಲೇಸ್ ಇಂದ ಇನ್ನೊಂದು ಪ್ಲೇಸಿಗೆ, if there is a height difference, right? Height difference, higher level ಇಂದ lower level ಗೆ water flow ಆಗ್ತದೆ, correct? Why water flows from higher level to lower level? There is a gravitational force, ಆ ಫೋರ್ಸ್ ಪುಲ್ ಮಾಡ್ತದೆ lower potential side ಗೆ, ಅಲ್ಲಿ ಲೆವೆಲ್ ಡಿಫರೆನ್ಸ್ ಇಸ್ ರಿಕ್ವೈರ್ಡ್. ಅದೇ ರೀತಿ ಕರೆಂಟ್ ಇಲ್ಲಿ ಚಾರ್ಜ್ ಫ್ಲೋ ಆಗಬೇಕಿದ್ರೆ ಏನಾಗಬೇಕು, ಇಲ್ಲಿ ಪೊಟೆನ್ಷಿಯಲ್ ಡಿಫರೆನ್ಸ್ ಅಪ್ಲೈ ಮಾಡಬೇಕು. ಒಂದು ಸೈಡ್ ಹೈಯರ್ ಪೊಟೆನ್ಷಿಯಲ್ ಇರಬೇಕು, ಇನ್ನೊಂದು ಕಡೆ ಲೋವರ್ ಪೊಟೆನ್ಷಿಯಲ್ ಇರಬೇಕು. ಇಫ್ ಯು ಅಪ್ಲೈ ದಿಸ್ ಪೊಟೆನ್ಷಿಯಲ್ ಡಿಫರೆನ್ಸ್ ಆರ್ ಬ್ಯಾಟರಿ, ಅವಾಗ ಇಲ್ಲಿರೋ ಫ್ರೀ ಎಲೆಕ್ಟ್ರಾನ್ ಏನಾಗ್ತದೆ, all this free electron starts to move in a particular direction. Electron is a negatively charged, correct? Electron is a negatively charged. ಆ ನೆಗೆಟಿವ್ ಚಾರ್ಜ್ ಏನಾಗಬೇಕು, ಆಲ್ ದಿಸ್ ನೆಗೆಟಿವ್ ಚಾರ್ಜ್ ಈ ಪಾಸಿಟಿವ್ ಚಾರ್ಜ್ ಕಡೆಗೆ ಮೂವ್ ಆಗ್ತದೆ, ಕರೆಕ್ಟ್? ಫಸ್ಟ್ ಗೆ ನಾವೇನು ಡಿಸ್ಕಸ್ ಮಾಡಿದ್ದೇವೆ, ಅನ್ಲೈಕ್ ಚಾರ್ಜ್ ಅಟ್ರಾಕ್ಟ್ ಈಚ್ ಅದರ್. ಅವಾಗ ಪಾಸಿಟಿವ್ ಸೈಡ್ ಗೆ ಈ ಎಲ್ಲ ಇಲೆಕ್ಟ್ರಾನ್ ಕೂಡ ಒಂದು ಕರೆಂಟ್ ಒಂದು ಕಡೆಗೆ ಡ್ರಿಫ್ಟ್ ಆಗ್ತದೆ, ಕರೆಕ್ಟ್? ಆಲ್ ದಿಸ್ ಚಾರ್ಜಸ್, ಎಲೆಕ್ಟ್ರಾನ್ಸ್, ಫ್ರೀ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಡ್ರಿಫ್ಟ್ ಇನ್ ಎ ಪರ್ಟಿಕ್ಯುಲರ್ ಡೈರೆಕ್ಷನ್, ಒಂದು ಪರ್ಟಿಕ್ಯುಲರ್ ಡೈರೆಕ್ಷನ್ ಕಡೆಗೆ ಡ್ರಿಫ್ಟ್ ಆಗ್ತದೆ, ಕರೆಕ್ಟ್? ಫೋರ್ಸ್ ಎಕ್ಸ್ಪೀರಿಯನ್ಸ್ ಆಗ್ತದೆ ಈ ಡೈರೆಕ್ಷನ್ ಅಲ್ಲಿ. ಆ ಫೋರ್ಸ್ ಏನು ಅಂತ ನೆಕ್ಸ್ಟ್ ಬರೀತೇನೆ, ಐ ವಿಲ್ ರೈಟ್ ದಟ್. ನೆಕ್ಸ್ಟ್ ಫೋರ್ಸ್, ಇಟ್ ವಿಲ್ ಎಕ್ಸ್ಪೀರಿಯನ್ಸ್ ಫೋರ್ಸ್ ಅಲಾಂಗ್ ದಿಸ್ ಡೈರೆಕ್ಷನ್. ಅವಾಗ ಏನಾಗ್ತದೆ, ಆಲ್ ದಿಸ್ ಫಸ್ಟ್ ಆಗ ಏನು ಬರ್ತೇನೆ ನಾನು, ಕರೆಂಟ್ ಈಸ್ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಆರ್ ಮೂವಿಂಗ್ ರ್ಯಾಂಡಮ್ಲಿ ಇನ್ ಆಲ್ ಡೈರೆಕ್ಷನ್. ರ್ಯಾಂಡಮ್ಲಿ ಇನ್ ಆಲ್ ಡೈರೆಕ್ಷನ್ ಆಗುವಾಗ ನೆಟ್ ಫ್ಲೋ ಏನಾಯ್ತು, ಝೀರೋ. ಅದಕ್ಕೆ ನಾನು ಕರೆಂಟ್ ಇಲ್ಲ ಅಂತ ಹೇಳಿದಲ್ಲಿ, ಝೀರೋ ಕರೆಂಟ್ ಅಂತ, ನೋ ಕರೆಂಟ್. ಬಟ್ ಈಗ ಏನಾಯ್ತು, ಆಲ್ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಸ್ಟಾರ್ಟ್ ಟು ಮೂವ್ ಇನ್ ಎ ಪರ್ಟಿಕ್ಯುಲರ್ ಡೈರೆಕ್ಷನ್. This produces a net flow of charges, correct? Now there is a net flow of charges. Net flow of charges. ಈಗ ಇಲ್ಲಿ ನೆಟ್ ಫ್ಲೋ ಆಫ್ ಚಾರ್ಜ್ ಇದೆ ಇನ್ ಎ ಪರ್ಟಿಕ್ಯುಲರ್ ಡೈರೆಕ್ಷನ್. ನೋಡಿ, ಎಲ್ಲ ಚಾರ್ಜ್ ಕೂಡ ಒಂದೇ ಡೈರೆಕ್ಷನ್ ಅಲ್ಲಿ ಮೂವ್ ಆಗ್ತಾ ಉಂಟು ಈಗ, ಕರೆಕ್ಟಾ? ದಟ್ ಮೀನ್ಸ್ ದೇರ್ ಎಕ್ಸಿಸ್ಟ್ ಎ ಕರೆಂಟ್. ಬಟ್ ವಾಟ್ ಇಸ್ ದ ಡೈರೆಕ್ಷನ್ ಆಫ್ ಕರೆಂಟ್? Direction of current is from a positive terminal to negative terminal of the battery. That is the direction of current we are assigning, correct? Someone have doubt? What is the doubt? You are correct. What is that? Yes. Okay. Yes. Yes. Okay. Now here net flow of charge. There is a flow of charge in a particular direction, correct? So that there is a current now. There is a current because all charges moving in a particular direction. Earlier what I said, if there is no potential difference applied, ಒಂದೊಂದು ಎಲೆಕ್ಟ್ರಾನ್ ಒಂದೊಂದು ಡಿಫರೆಂಟ್ ಡೈರೆಕ್ಷನ್ ಗೆ ಮೂವ್ ಆಗ್ತಾ ಉಂಟು, ಕರೆಕ್ಟಾ? ಬೇರೆ ಬೇರೆ ಡೈರೆಕ್ಷನ್ ಗೆ ಎಲೆಕ್ಟ್ರಾನ್ ಮೂವ್ ಆಗ್ತದೆ, ಲೈಕ್ ದಿಸ್ ಡಿಫರೆಂಟ್ ಡೈರೆಕ್ಷನ್. ಅವಾಗ ನೆಟ್ ರಿಸಲ್ಟೆಂಟ್ ತೆಗೆದಾಗ ಏನಾಯ್ತು, ಝೀರೋ, ಕರೆಕ್ಟಾ? ನೆಟ್ ಫ್ಲೋ ಝೀರೋ ಆಯ್ತು ಇಲ್ಲಿ, ನೆಟ್ ಫ್ಲೋ ಈಸ್ ಝೀರೋ ಇಲ್ಲಿ. Students, don't interact with yourself. In that comment session, what we get is you are interacting by yourself. Better you focus on subject and you ask any doubts with me. If you have any subject doubt, don't interact with yourself. If you repeat that, we'll remove you from that from the group. You will not get the classes. Please listen the class and ask doubts with me. If you have any doubts, any clarification required, I will do that. I will clarify here itself on the board. On the spot, I will clarify any doubts if you have related to competitive exam point of view, or any other doubts if you have. I will clarify here itself about if you want any information about the college, or any information about the institution, or any courses you want, any information about NEET or JEE coaching, or any other competitive coaching, everything I will explain for you. Or any subject related doubt also I will explain, but don't interact with yourself. Okay. Hope you understood, students. Now this I am discussing about net current. Now there is a current in this particular direction, but even though I told current is the rate of flow of a charge in a particular direction, that given here in the previous slide, there is no direction for current. Current is a scalar quantity. It is not a vector quantity. Electric current is not a vector quantity. Electric current is a scalar quantity. Okay. Electric current I is a scalar quantity. It is a scalar quantity. It is not a vector quantity. Why it is a scalar quantity? How I defined I is equal to rate of flow of a charge. That is rate of flow means charge per time. Charge per time. Once again I will write here. Charge by time. What is electric charge? Charge is a scalar quantity. And time is a scalar quantity. Charge is a scalar, time is a scalar, and current is a scalar. And another concept is there, even though we represent a direction here, it does not follow law of vector additions. Vector ಅಂತ ಹೇಳಬೇಕಿದ್ರೆ ಅದರದೇ ಆದ ಲಾಸ್ ಇದೆ, loss of vector addition ಇದೆ. If this electric current follows that law of vector addition, then only we can say it is a vector quantity. But this current, electric current, even though we represent a direction here, ಇಲ್ಲಿ ನಾವು ಡೈರೆಕ್ಷನ್ ಬರೆದ್ರೂ ಕೂಡ it does not follow laws of vector addition. Because it does not follow laws of vector addition, we are saying it as a scalar quantity. It is not a vector quantity. Okay. Now I have to get a unit of this electric current. Electric current in a unit ಬೇಕು ನಮಗೆ, SI unit. ನಾನು ಆಗಲೇ ಹೇಳಿದೆ how to get SI unit ಅಂತ. ಯಾವುದೇ ಒಂದು ಫಂಡಮೆಂಟಲ್ ಕ್ವಾಂಟಿಟಿಯ ಯೂನಿಟ್ಸ್ ಗೊತ್ತಿದ್ರೆ we have to get its unit, derived quantity units ನಾವು find out ಮಾಡಬೇಕು. How I can find out? Charge in unit ಗೊತ್ತಿದೆ. What is the unit of charge? Unit of charge is Coulomb. Time in a unit ಗೊತ್ತಿದೆ. What is the unit of time? SI unit. Time we measure in terms of second, right? Divided by second. If I take a second to numerator, what we get? Coulomb per second ಆಯ್ತು. ಕರೆಕ್ಟಾ? Coulomb per second ಆಯ್ತು. ಕರೆಕ್ಟಾ? Coulomb per second. This is called as a ampere. Ampere, capital A is a representation. Ampere is a scientist name. AMPERE. Ampere. Scientist name ಬರೆಯುವಾಗ small letter ಅಲ್ಲಿ ಬರಬೇಕು. Unit ಬರೆಯುವಾಗ scientist name ಅಲ್ಲಿ, if it is in a symbol capital letter E, is a unit. Ampere is the unit of SI unit of current. Ampere or Coulomb per second also we can write. ನೀವು ಆಂಪಿಯರ್ ಬರೀಬಹುದು ಅಥವಾ Coulomb per second also you can write. Both are correct. Both are SI system ಅಲ್ಲೇ ಇದೆ. Now I have to define ampere. How I can define ampere? In terms of Coulomb per second I can define, right? When current is said to be 1 ampere, equation nodili, equation. In this equation, based on this equation, I can define 1 ampere. Current is 1 ampere. When current is said to be 1 ampere, current is equivalent to 1 ampere. 1 ampere is equal to 1 coulomb of charge flowing in 1 second, right? If you have a conductor, ಈ ಕಂಡಕ್ಟರ್ ಅಲ್ಲಿ 1 ಸೆಕೆಂಡ್ ಅಲ್ಲಿ 1 coulomb of charge flow ಆದ್ರೆ 1 coulomb of charge flow ಆದ್ರೆ we can say current is 1 ampere. Correct? By using this we can define 1 ampere. Current is said to be 1 ampere if 1 coulomb of charge is flowing through the conductor in 1 second. 1 second ಅಲ್ಲಿ 1 coulomb charge flow ಆದ್ರೆ ನಮಗೆ 1 ಆಂಪಿಯರ್ ಕರೆಂಟ್ ಸಿಗ್ತದೆ. ಕರೆಕ್ಟಾ? 1 coulomb ಚಾರ್ಜ್ ಅಂದ್ರೆ ಎಷ್ಟು ಚಾರ್ಜ್ ಫ್ಲೋ ಆಗಬೇಕಲ್ಲ, ಎಷ್ಟು ಎಲೆಕ್ಟ್ರಾನ್ ಫ್ಲೋ ಆಗಬೇಕು? ಹೌ ಟು ಫೈಂಡ್ ದಟ್? ನಮಗೆ 1 coulomb ಆಫ್ ಚಾರ್ಜ್ ಅಂತ ಹೇಳ್ತೇವೆ. 1 coulomb ಆಫ್ ಚಾರ್ಜ್ ಅಂದ್ರೆ ಹೇಗೆ ಗೊತ್ತಾಗ್ತದೆ ನಿಮಗೆ ಎಷ್ಟು ಅಂತ? ಎಷ್ಟು ಗೊತ್ತಾಗ್ತದೆ? 1 ampere is equal to how many joules? Say ampere is the current, joule is the energy unit. ಒಂದು ಡೌಟ್ ಕೇಳಿದಿರಿ ಯಾರು? That doubt is 1 ampere is in terms of joule you are asking. Say ampere is the current unit, ampere is the current unit, and this joule is the energy unit. I will define that in terms of joule using a power. Power ಅಂದ್ರೆ energy by time ಆಯ್ತು. Energy is a joule ಅಲ್ಲಿ ಆ ಫಾರ್ಮ್ಯಾಟ್ ಅಲ್ಲಿ we can explain that. 1 ampere is not equal to 1 joule. Okay, 1 ampere is not equal to 1 joule. We cannot define like that. We cannot define like that. ನಾವು ಕರೆಂಟ್ ಅನ್ನು ಪವರ್ ಗೆ ಬರೆದು ಪವರ್ ಇಸ್ ಜೌಲ್ ಪರ್ ಸೆಕೆಂಡ್ ಇಸ್ ಅ ಪವರ್. ಆ ಜೌಲ್ ಪರ್ ಸೆಕೆಂಡ್ ಇಸ್ ದ ಪವರ್ ಅಲ್ಲಿ ನಾವು ಡಿಫೈನ್ ಮಾಡಬೇಕು. ದಟ್ ಐ ವಿಲ್ ಡಿಫೈನ್ ಲೇಟರ್. ಓಕೆ, ಪವರ್ ಡಿಫೈನ್ ಮಾಡುವಾಗ ಐ ವಿಲ್ ಡಿಫೈನ್ ದಟ್. ನಾವು ಐ ನೀಡ್ ಕೂಲಂಬ್. ಐ 1 ಕೂಲಂಬ್ ಅಂದ್ರೆ ಎಷ್ಟು ಎಲೆಕ್ಟ್ರಾನ್ ಬರ್ತದೆ ಅಲ್ಲಿ? We have a quantization concept, correct? Quantization concept, to define this 1 coulomb, I will take this Q charge. Charge Q is equal to total charge of the system is Q is equal to N times E into baribodu, correct? If you have any system of charges or group of charges, its total charge is N times E. What is E? E is the charge of electron, correct? E is the charge of electron. E is the charge of electron. What is the charge of electron? E value is 1.6 into 10 power minus 19 coulomb, correct? This is a value of electronic charge. Suppose ನಿಮ್ಮ ಚಾರ್ಜ್ Q ವ್ಯಾಲ್ಯೂ ಆಫ್ ಚಾರ್ಜ್ ಅಥವಾ ಒಂದು ಸಿಸ್ಟಮ್ ಅಲ್ಲಿ n ನಂಬರ್ ಆಫ್ ಎಲೆಕ್ಟ್ರಾನ್ ಇದ್ರೆ, if there are n number of electron, n may be any number, 1 ಇರಬಹುದು, 2 ಇರಬಹುದು, 3, 4 up to infinite. In your system there are n number of charges. N may be 1. If there is only 1 electron, what is the charge of the system? 1 times E. E is equal to this much. If there are 10 electrons, n is a 10 ಆಯಿತು, correct? N is a 10. N is 10. Based on this equation we can find the amount of charges. N we can find, that is N is equal to Q by E ಬರೆಯುವುದು, correct? N is equal to Q by E we can write. What is the Q? Q is the total charge of the system and E is the charge of each electron. ನನಗೇನು ಬೇಕಲ್ಲಿ? I have defined current rate. What I defined? I is equal to Q by T and 1 ampere I defined. 1 ampere is equal to 1 coulomb per second, correct? 1 coulomb charge 1 ಸೆಕೆಂಡ್ ಅಲ್ಲಿ ಫ್ಲೋ ಆದ್ರೆ ಕರೆಂಟ್ ಈಸ್ 1 ಆಂಪಿಯರ್, ಕರೆಕ್ಟ್? ನನಗೆ 1 ಕೂಲಂಬ್ ಅಂದ್ರೆ ಎಷ್ಟು ಚಾರ್ಜ್ ಫ್ಲೋ ಆಗಬೇಕಲ್ಲಿ, ಎಷ್ಟು ಎಲೆಕ್ಟ್ರಾನ್ ಫ್ಲೋ ಆಗಬೇಕಲ್ಲಿ? 1 ಕೂಲಂಬ್ ಅಂದ್ರೆ ಎಷ್ಟು ಎಲೆಕ್ಟ್ರಾನ್ ಫ್ಲೋ ಆಗಬೇಕು? ಹೌ ಐ ಕ್ಯಾನ್ ಫೈಂಡ್? Q is equal to 1 coulomb ಆಯ್ತು, ಕರೆಕ್ಟ್? Q is equal to 1 coulomb. If Q is equal to 1 coulomb, Q is equal to 1 coulomb, then what is N? Then number of electrons equal to how much? Number of electron equal to how much? How I can get this? How I can get this? Use this equation, right? Use this equation. N is equal to Q ಕೊಟ್ಟಿದ್ದಾರೆ ಇಲ್ಲಿ 1 ಕೂಲಂಬ್ ಆಯಿತು 1 divided by electron charge ಎಷ್ಟು ಇಲ್ಲಿ electron charge is given here ಎಷ್ಟು ಇಲ್ಲಿದೆ electron charge is 1.6 into 10 power minus 19 is the electron charge, correct? Now you divide this. See students, this is a standard number. In many problems, many numericals, we get this value we get, correct? 1 by 1.6. This value we have to remember. If you simplify this 1 by 1.6, its value is 0.625. 0.625. This standard number. ಇದು ಗೊತ್ತಿರಬೇಕು ನಮಗೆ. We should remember this. 1 by 1.6 is 0.625 into 10 power minus 19. If I take the numerator, what happens? 10 power minus 19. ಅದನ್ನು ನ್ಯೂಮರೇಟರ್ ಗೆ ತಗೊಂಡು ಹೋಗಿ ಏನಾಗ್ತದೆ? ನ್ಯೂಮರೇಟರ್ ಗೆ ತಂದ್ರೆ 10 power plus 19 ಆಯಿತು, ಕರೆಕ್ಟಾ? 10 power plus 19 ಸರಿಯಾ? What is this? This is the number of electrons. ಈ ನಂಬರ್ ನೋಡಿ ಇಲ್ಲಿ 0.625 into 10 power 19, or I will write this as 6.25 into 10 power 18 electrons, correct? Electrons ಅಂದ್ರೆ ನಮಗೆ ಈಗ 1 ಕೂಲಂಬ್ ಅಂದ್ರೆ ಏನಾಯ್ತು? 1 ಆಂಪಿಯರ್ ಅಂದ್ರೆ ಏನಾಯ್ತು? 1 ಕೂಲಂಬ್ ಆಫ್ ಚಾರ್ಜ್ ಫ್ಲೋಯಿಂಗ್ ಇನ್ 1 ಸೆಕೆಂಡ್. 1 ಕೂಲಂಬ್ ಅಂದ್ರೆ ಎಷ್ಟು ಎಲೆಕ್ಟ್ರಾನ್? 6.25 into 10 power 18 ಅಂದ್ರೆ 6.25 ಹಾಕಿ 18 zeros ಬರಬೇಕು. 18 zeros ಅಂದ್ರೆ it is a very large number, very large number. ಇಷ್ಟು ನಂಬರ್ ಆಫ್ ಎಲೆಕ್ಟ್ರಾನ್ 1 ಸೆಕೆಂಡ್ ಅಲ್ಲಿ ಫ್ಲೋ ಆದ್ರೆ we get current 1 ampere. Now students, question is 1 milliampere current ಅಂದ್ರೆ ಎಷ್ಟು ಎಲೆಕ್ಟ್ರಾನ್ಸ್? ನಾವು ಫೈಂಡ್ ಔಟ್ ಮಾಡಬೇಕು. I have to get 1 milliampere current. 1 milliampere current ಬರಬೇಕಿದ್ರೆ ಎಷ್ಟು ಚಾರ್ಜ್ ಫ್ಲೋ ಆಗಬೇಕು ಅಂತ ಫೈಂಡ್ ಔಟ್ ಮಾಡಬೇಕು. How to find? ನಾನು ಈ ಈಕ್ವೇಷನ್ ಅನ್ನು ಮಾಡಿಫೈ ಮಾಡ್ತೇನೆ. I will modify this equation as so Q. What is Q? Q is equal to NE. Q is equal to NE. I can write this as NE divided by T, correct? NE by T. ಸರಿಯಾ? NE by T ಬರೆದೆ. Now 1 ampere I calculated. 1 ampere ಅಲ್ಲಿ ಇಷ್ಟು ಎಲೆಕ್ಟ್ರಾನ್ ಫ್ಲೋ ಆಗ್ತದೆ. ನಾವು ಈಗ 1 ಮಿಲಿ ಆಂಪಿಯರ್ ಕರೆಂಟ್ ಅಲ್ಲಿ ಫೈಂಡ್ ಔಟ್ ಮಾಡಬೇಕು. 1 ಮಿಲಿ ಆಂಪಿಯರ್. What is my question is what is the number of electrons flowing in 1 milliampere current? 1 milliampere current ಆಗಬೇಕಿದ್ರೆ ಎಷ್ಟು ಎಲೆಕ್ಟ್ರಾನ್ ಫ್ಲೋ ಆಗಬೇಕಲ್ಲ ಅಂತ, ಕರೆಕ್ಟಾ? How I can find 1 milliampere? ಇಲ್ಲಿ ಕರೆಂಟ್ I ಎಷ್ಟಾಯ್ತು? ಈ ಈಕ್ವೇಷನ್ ನೋಡಿ. Look into this equation. ಈ ಈಕ್ವೇಷನ್ ತಗೊಳ್ಳಿ. I is equal to NE by T. First I will write equation. I is equal to NE by T. What I require? N ಬೇಕು, number of electron flowing in 1 milliampere ಬೇಕು, ಕರೆಕ್ಟಾ? ಏನು ಮಾಡಬೇಕಿಲ್ಲಿ? N I will take. N is equal to I into T modify ಮಾಡಿ equation divide by E ಆಯ್ತು, ಸರಿಯಾ? divide by E ಆಯ್ತು. This I will substitute. ಕರೆಂಟ್ ಎಷ್ಟು ಬೇಕು ನಂಗೆ ಇಲ್ಲಿ? 1 milliampere. 1 milliampere ಅಂದ್ರೆ ಎಷ್ಟು ಆಂಪಿಯರ್? 1 milliampere is ampere is 10 power minus 3. Yes, ಯಾರೊಬ್ರು ಆನ್ಸರ್ ಮಾಡಿದಿರಲ್ಲಿ? ಯಾರೊಬ್ರು ಕರೆಕ್ಟ್ ಆನ್ಸರ್ ಮಾಡಿದರೆ 10 power minus 3. 1 milliampere means 10 power minus 3 ampere ಆಯಿತು. ಇಂಟು ಟೈಮ್ ಎಷ್ಟು? 1 ಸೆಕೆಂಡ್. ಟೈಮ್ 1 ಸೆಕೆಂಡ್. ಕರೆಂಟು ಇನ್ನು ಪರ್ ಸೆಕೆಂಡ್ ಅಲ್ಲ, ಪರ್ ಸೆಕೆಂಡ್ ಕರೆಂಟಿನ ಮೀನಿಂಗ್ 1 ಸೆಕೆಂಡ್. ಟೈಮ್ ಇಸ್ 1 ಸೆಕೆಂಡ್. ಎಲೆಕ್ಟ್ರಾನ್ ಚಾರ್ಜ್ ಎಲ್ಲಿದೆ? ಇಲ್ಲೆಲ್ಲೋ ಬರೆದಿದ್ದೇನೆ ಎಲೆಕ್ಟ್ರಾನ್ ಚಾರ್ಜ್. I have given here electron charge, correct? This is electron charge. Electron charge is 1.6 into 10 power minus 19. Then simplify ಮಾಡಿ solve this. See ಏನು ಮಾಡಬೇಕಿಲ್ಲಿ, which one you should remember? 1 by 1.6 value you should remember, right? 1 by 1.6 value you should remember is to 0.625. Next 10 power we have to solve. This is a easy method. 10 powers separately we have to solve. Don't mix up this. Don't write 10 power minus 3 as 0.001. Don't write that. You have to write 10 power minus 3 itself. Then you can easily solve this 10 to the powers. 10 to the powers you can easily simplify. First you solve 1 by 1.6. 1 by 1.6 how much? 1 by 1.6 how much? That is 0. Same number 625. 625 into, now I have to write 10 to the power, right? 10 to the power. How I can write 10 to the powers now? 10 to the power minus 19 here, take to numerator. 10 to the power minus 19 and numerator plus 19. 10 to the power plus 19 and minus 3. ಎಷ್ಟು ಉಳಿಯಿತು? 10 to the power, while write one more step, minus 3 ಹಾಗೆ ಬರೀತೇನೆ. I will take this to numerator. Numerator ಗೆ ತಂದ್ರೆ ಏನಾಯಿತು? plus 19. 10 power plus 19. Total ಎಷ್ಟು ಆಯಿತು? plus 19 minus 3 is plus 16 ಆಯಿತು. ಕರೆಕ್ಟಾ? plus 16. That is, I'll write this here. I'll write here. Correct? Illi kaantadalla? Yes. I'll write this here. 0.625 into 10 power 16. Correct? 16. This is the number of electron flowing in 1 milliampere current. Correct? 1 milliampere current. ಅಂದರೆ 1 ಮಿಲಿಯಂಪಿಯರ್ ಕರೆಂಟ್ ಅಂತ ನಿಮಗೆ ಸಣ್ಣ ನಂಬರ್ ಕೇಳಬಹುದು, ಬಟ್ ಅಷ್ಟು ಸಣ್ಣ ಕರೆಂಟ್ ಆದ್ರೂ, ಸಣ್ಣ ವ್ಯಾಲ್ಯೂ ಆದ್ರೂ ಇಷ್ಟು ಇಲೆಕ್ಟ್ರಾನ್ ಪರ್ ಸೆಕೆಂಡ್ ಅಲ್ಲಿ ಫ್ಲೋ ಆಗ್ತದೆ ಥ್ರೂ ದ ವೈರ್. ದಿಸ್ ಮಚ್ ಇಲೆಕ್ಟ್ರಾನ್ ಫ್ಲೋಯಿಂಗ್ ಪರ್ ಸೆಕೆಂಡ್. ಇಸ್ ಇಟ್ ಕ್ಲಿಯರ್? ಕರೆಕ್ಟಾ? ದಿಸ್ ಇಸ್ ಹೌ ವಿ ಕ್ಯಾನ್ ಕ್ಯಾಲ್ಕುಲೇಟ್. ಇನ್ ದ ಸಿಮಿಲರ್ ವೇ 1 ಮಿಲಿಯಂಪಿಯರ್ ಆಯ್ತು, ಮೈಕ್ರೋ ಆಂಪಿಯರ್ ಇರಬಹುದು, ಮೈಕ್ರೋ ಆಂಪಿಯರ್ ಆರ್ 0.5 ಮಿಲಿಯಂಪಿಯರ್. ಡಿಫರೆಂಟ್ ಕೇಸಸ್ ವಿ ಕ್ಯಾನ್ ಸಿಂಪ್ಲಿಫೈ. ಬೇಕಾದಷ್ಟು ನಾವು ಸಾಲ್ವ್ ಮಾಡಬಹುದು. ರೈಟ್? ಡಿಫರೆಂಟ್ ಸಚ್ ಕ್ಯಾಲ್ಕುಲೇಷನ್ಸ್, ಎವ್ರಿಥಿಂಗ್ ವಿಲ್ ಡಿಸ್ಕಸ್. ಸ್ಟೂಡೆಂಟ್ಸ್, now I will conclude my today's topics here. Next session I will discuss about potential difference, ಬೇರೆ potential difference, potential energy concept, work done. Based on that, different values of current ಅನ್ನು ಹೇಗೆ ಇನ್ ಶಾರ್ಟ್ ಆಗಿ ಹೇಗೆ ಸಾಲ್ವ್ ಮಾಡಬಹುದು, ಅಂಡ್ ಕಾಂಬಿನೇಷನ್, ರೆಸಿಸ್ಟೆನ್ಸ್ ಎಲ್ಲವನ್ನು ಡಿಟೇಲ್ ಆಗಿ ವಿಲ್ ಡಿಸ್ಕಸ್. ಅಲಾಂಗ್ ವಿತ್ ದಟ್, ಕಾಂಪಿಟೇಟಿವ್ ನೀಟ್ ಜೆಇಗೆ ನಿಮಗೆ ಹೆಲ್ಪ್ ಆಗುವ ಹಾಗೆ ತುಂಬಾ ಶಾರ್ಟ್ ಕಟ್ ಮೆಥಡ್ಸ್ ಎಲ್ಲವನ್ನು ನಾನು ಎಕ್ಸ್ಪ್ಲೈನ್ ಮಾಡ್ತೇನೆ ಇಲ್ಲಿ. ಫಾರ್ ಯುವರ್ ಫ್ಯೂಚರ್ ಇನ್ ಯುವರ್ PUC ಗೆ ನೀವು ಬರುವಾಗ ನಿಮಗೆ ಈ ಎಲ್ಲ ಟಾಪಿಕ್ಸ್ ಕೂಡ ಡೈರೆಕ್ಟ್ ಆಗಿ ನೋಡಿದ ಕೂಡಲೇ ಸಾಲ್ವ್ ಮಾಡುವ ಹಾಗೆ I will give the shortcut hints, everything I will give here. Please join in the next sessions also. Next sessions alli innashtu additional concept ಒಟ್ಟಿಗೆ will join once again. Thank you.